A question of if we will experience a major windstorm over the late fall and winter. It's more an issue of when and where. And that can make all the difference when we're talking about damage. Galloping Gertie is the icon of northwest windstorms. But the November 1940 storm that shattered it otherwise barely rates a notice.
We're operating here by candlelight, but I can just see that wind gauge over there. It looks as though we had something over 60 on that one. There's one up over 80.
At the top of the list, the Columbus Day storm of 1962. Possibly the strongest non-tropical storm to hit the United States in the 20th century. Peak gusts reached 179 miles per hour.
They said it was coming, and it's here.
In second place, the storm of December 2006. Winds knocked out power to more than 1 million customers, some for more than a week. These historic windstorms, or bombs as they're called, develop and strike most frequently from November to February. It's one thing to forecast a windstorm, but it's another to understand its impact on us and on our property. That's what brought us to the University of Washington's Kirsten Wind Tunnel. Tunnel operators can generate winds up to 200 miles per hour. I have no plans to go that high. My goal is to show what common wind speeds look like. 10 miles per hour, the flag is beginning to extend out and rustle. We begin to see the leaves moving as well. At 20, the flag is fully extended and snapping, and the whole plant is beginning to strain. 30 to 35 is a critical wind speed range in the early to mid-autumn months when plants are still fully leafed out. They bend more, they're more likely to break. The leaves act essentially like a sail. They catch the full force of the wind and transfer it to the tree. Once the leaves are gone, the magic wind speed for damage is usually 40 miles per hour. That's also the speed at which the Hood Canal Bridge closes. A wind of 50 will close the 520 bridge over Lake Washington. Such windstorms tend to follow similar paths, developing over warmer waters well off the California coast, then curving toward the northwest. The most dangerous ones make landfall over Vancouver Island. We know that track creates damaging winds at different times in different neighborhoods. Now, as a low passes off the coast to my west, wind accelerates toward it from the east, over the Cascade passes and down the foothills. That's similar to the way the Snoqualmie River accelerates between those boulders and over the falls, right toward where I'm standing. Here's my watch list for the neighborhoods most sensitive to destructive winds before the storm arrives. The Columbia Gorge from Washougal to Vancouver, downstream from Natchez Pass, from Enumclaw to Black Diamond. The Snoqualmie River outflow from North Bend toward Issaquah. The Fraser River outflow from Linden to Bellingham. Another sensitive spot, the north end of Hood Canal. Frequently, strong westerly winds slam into Whidbey Island and from Mukilteo to Marysville. Paired with windstorms in terms of destructive power are heavy rains. Shannon O'Donnell takes a look at those.
That's right, Jeff. And as we see year after year, financially and emotionally, no other weather phenomenon can do more damage. And flooding that results from heavy, relentless rain is our #1 local weather disaster.
Seattle may have a soggy image, but most of us know Puget Sound rainfall as more drizzle than downpour. But when heavy rains hit, it can be disastrous.
You've no doubt heard the term Pineapple Express, a phrase coined to describe the virtual hose of moisture pointed straight at the northwest.
Not only does it bring very heavy rain to the lowlands, but because it's so warm, it forces the snow level to go way up. That ends up melting a lot of lower elevation snow that's already fallen. The combination of that melting snow and torrential rainfall makes widespread northwest flooding a certainty. You'll remember the most recent Pineapple Express event. It's the one that struck just last December. Hardest hit this time was the southwestern corner of the state, as days of warm rain made for massive flooding of the Chehalis Valley. One spot near the Willapa Hills recorded 9 inches of rain within 24 hours. Part of I-5 was shut down as the water overtook the land, destroying countless homes and businesses. Although the Chehalis Valley bore the brunt of last year's flooding, many communities are vulnerable in such a scenario.
Man-made levees like this surround most of the rivers in western Washington, but when flooding's in the forecast, you need to sandbag too.
Well, we could start at the Nooksack and work all the way down to Lewis County.
Okay.
Skagit County is probably the second worst river on the west coast.
The Army Corps of Engineers works with dike districts around western Washington to prepare for the next round of rising water. On this crisp autumn afternoon, Eric Winters helped the Corps perfect their sandbagging technique. They'll then go on to train others in communities all around Puget Sound. Sometimes the levees and sandbags can only help so much, and the race is on to protect lives and preserve livelihoods. Raised platforms of soil called farm pads are becoming a popular means for farmers to gather livestock and machinery when all else fails. Because sometimes it really does rain too much in Seattle.
Around here, snow can fall as early as October or as late as mid-April. When it does fall, it may just dust a few locations, causing minor school delays and a little bit of excitement. Other times, it can cripple cities and strand thousands. Meteorologist Chris Warren takes a look at why it can vary so widely, depending on where you live.
Snow, a four-letter word and one we do not throw around lightly. It can change your plans for better or worse. When there's talk of snow, there are specific ingredients we look for. To see snow in western Washington, it's a pretty simple recipe. We need freezing temperatures and moisture. The Pacific Ocean and the Puget Sound give us plenty of moisture. Cold winter air moving south from the British Columbia interior can push us below freezing. But combining both ingredients at the same time is more difficult. One basic scenario develops when an area of low pressure moves over the water just long enough to pick up moisture, but if it stays there too long, the mild ocean water will warm the air and then we see rain instead of snow. Because of this warming effect of the water in marginal situations, you're most likely to find snow inland away from the Sound. Another way we can see snow is when it comes from the north as an Arctic front. The front lifts the moist ocean air over the Puget Sound region. And we end up with a major snow and ice event like we saw in November of 2006, when Quest Field looks more like the frozen tundra the Green Bay Packers are used to. We also have a few wild cards, what may be surprise snow for some. And elevation plays a big role.
Here on Cougar Mountain, the elevation is about 1,500 feet. If the freezing level was also at 1,500 feet, if it was 32 degrees right here, it would make sense that we would see snow. Meanwhile, when you drive down about halfway, temperatures will be a little bit warmer than freezing, and we can still see snow. The reason, it takes a while for snow to melt once it enters that warmer air, so we can see snow falling or even sticking about 1,000 feet below what we call the freezing level.
In heavier showers, you may find snow as much as 2,000 feet below the freezing level. At times, the snow may drag cold air to the surface, lowering the freezing level. If the snow falls long enough, we can see some temporary and spotty accumulations. We also have our version of lake effect snow, famous in the Midwest. When very cold air moves across the eastern strait, it gains moisture, and when it's forced up the side of the Olympics, we can see snow around Port Angeles while everyone else is dry. Whether the snow is hit and miss or a widespread hit, snow in western Washington deserves the attention it gets.
As we head up into the mountains, we can see some much bigger amounts of snow. Some locations in the Cascades and Olympics receive over 50 feet of snowfall on average each winter. Rich Marriott is an expert on snow and avalanches.
Jeff, the Northwest is famous for its deep snowpacks, but like anything else, you can get too much of a good thing. On the positive side, these huge snowpacks provide us with water and electricity during the dry summer months. And it gives us lots of fun things to do during the winter. But too much snow can give us headaches, especially for travelers through the Cascade Passes. In 2005 and 6, Washington DOT plowed off enough snow to fill Quest Field more than 7 times. And when it falls in certain patterns, it can become a powerful and dangerous force, an avalanche burying everything in its path. Last winter, Snoqualmie Pass was closed by snowfall and avalanches for over 175 hours, costing Washington's economy almost $50 million. And there is a human toll. A record 9 people died in backcountry avalanches in our state last winter. Avalanches aren't just caused by a lot of snow, but by the way it falls. Variations in the temperature, the winds, even the humidity produce layers in the snow.
So this is our top crust right here.
Most layers stick together and just pile up, but sometimes a weak layer can show up where the snow above isn't well attached to the underlying layer. Like a melting slice of ice cream, a slab avalanche can easily slide off an underlying layer.